Using the given permutation in S8, let us express it as a product of transpositions. Now, transpositions are actually considered as cycles of length 2. When you say a transposition, say for example, this permutation here in S8, just for example, okay, the transposition is 1 and 5. That would mean that 1 is mapped to 5 and 5 is mapped to 1. And the rest of the elements are mapped to themselves. So we need to try writing this permutation as a product of transposition. But there is a unique process once we already identified the expression of a product of disjoint cycles that would result this given permutation. We already done that using the previous video. You might want to check that. Okay, we already done doing that. You might want to check the previous video posted in determining an expression for this given permutation as a product of disjoint cycles. We have 3 different cycles during that time. You have here, we have, 1 and 8. We have another cycle 3, 6, and 4. And you have here 5 and 7. Notice that in that specific video, the given permutation is not a cycle. But using these 3 disjoint cycles, we're able to result to our given, our given permutation. Now, from this expression of a product of disjoint cycles, we could come up with an expression that is a product of transpositions. So we can express transposition in this manner. Now 1/8 here is already a transposition because it has a length of 2. You have only 2 elements there. So it stands as it is. Now let's proceed to 3, 6, and 4. So you have 3, 6, and 4 here can be expressed as a product of transposition. Okay? This is how we do it. We are going to copy, or of course it's a transposition, it should contain 2 elements. So we are going to have here 3. We'll be using the first element and 3 here as well. And since we have 3 elements here, there will be 2 transpositions that will result to our given cycle here. And that is actually in this pattern. The farthest away from 3 will be placed here and then going to that direction. So 3, 4, and then 3, 6. Let's check if this 2 would result to our given cycle here. So if you have, again, the rest of the numbers in S8, that's 2, 5, 1. I forgot 1. 1, 2, 5, 7, 8 are mapped to themselves. But for 3, 6, 4, we have this mapping. So for 3, okay, 3 is mapped to 6. So you'll have here 3 is mapped to 6. Okay, 3 is mapped to 6, 6 is mapped to 6. For 4, 4 is mapped to 4, 4 is mapped to 3. Okay, and then for 6, 6 is mapped to 3, 3 is mapped to 4. So 6 is mapped to 4, and 4 is mapped to 3. So that's the same thing as this given here. So that is how you write transposition for a cycle with length more than 2. So we use the first element, and then we pair it with the farthest, and then going from right to left. That's also the same. By the way, your 5, 7 here is already a transposition. That would mean we can express this as this new form using transpositions. You have 1, 8. Now 3, 6, 4 can be expressed in this manner. So 3, 4, and then you have here 3, 6. Then you have 5 and 7. So we have 4 transpositions that will result to the said permutation, as this already satisfies the given permutation on a specific identified video. Let's try to check if that is the case. So let's have a permutation with all of these 4 transpositions in S8. 1, 2, 3, 4, 5, 6, 7, and 8. So let's start from right to left. 1 is mapped to 1, 1 is mapped to 1, 1 is mapped to 1, 1 is mapped to 8. Let's have 2. 2 is mapped to 2, 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 so we have 2. For 3, 3 is mapped to 3, 3 is mapped to 6. Take note, we are now on 6. 6 is mapped to 6, 6 is mapped to 6. How about 4? 4 is mapped to 4, 4 is mapped to 4. 4 is mapped to 3. Now we are on 3. 3 is mapped to 3. How about 5? 5 is mapped to 7. We are now at 7. 7 is mapped to 7. 7 is mapped to 7. 7 is mapped to 7. How about 6? 6 is mapped to 6. 6 is mapped to 3. But here, we are now at the 3. 3 is mapped to 4. Now we are here in 4. 4 is mapped to 4. How about 7? 7 is mapped to 5. 5 is mapped to 5. 5 is mapped to 5. 5 is mapped to 5. And finally, for 8, 8 is mapped to 8. 8 is mapped to 8. 8 is mapped to 8. 8 is mapped to 1. Is this the same as the given permutation? 8, 2, 6, 3, 7, 4, 5, and 1? The answer is yes. So this permutation given, when expressed as a product of transpositions, is just equal to this entire expression. Let me rewrite it here. 1, 8, 3, 4, 3, 6, 5, and then 7. So we have 4 transpositions that when multiplied will result to our given permutation. Thank you very much for watching.